In this video, we're going to take a look at the graphs of ellipses. And the first thing we're going to look at is the geometric definition of an ellipse. And that is, an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points, which are called the foci, is a constant. And let's take a look at this picture here, and I'll talk about what that means. Basically, it means that any point we choose on the ellipse, if we take a line from that point to each focus, we add the distances together for those two line segments. That should be the same as if we take any other point on the ellipse, connect that point to each focus, add up the two lengths. That should be the same for both points. So the sum of these two distances should be a constant. And furthermore, if we take specifically one of these points here, that's on what's called the major axis, the longer axis for the ellipse, if we connect that point to each focus, we can see that the sum of those two lengths, the distances, should be the same as the distance all the way across from one edge of that ellipse to the other edge along the long axis. So the sum of the distances, sum of those lengths, should all be, if these coordinates are a and negative a, that total length should be 2a, and it has to be the same for any point in that ellipse. Okay, so next let's take a look at what the equations look like and how they're related to various features on the graphs. So an ellipse, if the center is at the origin, is either going to have its axis, the major axis, the long axis, on the y-axis or on the x-axis. And the way that's determined is by which coordinate has the larger denominator underneath it. So the way the convention is here is that a is the larger value, and a and b are both positive. So a is greater than b and both are positive. So you can see if a, the larger value, is underneath the y, or the y squared, then we get a vertical major axis. But if a squared, the larger value, is underneath the x squared, then we get a horizontal major axis. The vertices are the endpoints of the major axis. And you can see here in this equation, if x is 0, we have y squared over a squared equals 1. So y would have to be positive or negative a. Similarly, on the other side here, for the horizontal major axis, if y is 0, then we have x squared over a squared equals 1. So x would have to be positive or negative a. So we can see that that a value is connected to the location of the vertices, the endpoints of the major axis. The major axis for this one would be along, it's vertical, along the y-axis, and the length would be 2a. On the minor axis, which would be the horizontal axis, the endpoints for that axis are going to be on the x-axis, so y is 0. And notice if y is 0, then I have x squared over b squared equals 1, so x would have to be plus or minus b. So the endpoints would be negative b0 and b0. It's going to be horizontal, and the length would be 2b. Oops. The foci are those the points that are part of the geometric property, and they're located at 0 plus or minus c, where the relationship between a and b and c is this, that c squared is a squared minus b squared. That's the same relationship between A and B and C, no matter which orientation the axis has. If we have a horizontal major axis, its length is also 2a, because a is always, a squared is the denominator underneath, the denominator that determines the major axis. And then the minor axis would be vertical, and its length would be 2b. And now the foci are on the x-axis, so the y-coordinate is 0. We have plus or minus c, 0. So the key is figuring out which variable has the larger denominator underneath it, and that determines whether we have a horizontal or a vertical major axis. And then also remembering that c squared is a squared minus b squared. So, first example, we want to find the vertices, foci, and length of each axis and sketch the graph for this ellipse. So we know that it's an ellipse because we have two terms that are added together, two squared terms, and they have the same sign. They're both positive in this case, but if they were both negative, then we could divide everything by -1 and they would both be positive. So we want to figure out, it looks like 25 is larger, so that's a squared. 9 is smaller, that's b squared. It helps to establish a squared, b squared, and c squared right away. So a would be 5. Remember, we always take the positive value. Certainly there are two solutions to a squared equals 25, but we want the positive one. B squared is 9, that means b is 3. C squared is a squared minus b squared, so in this case that's 16. So c would be 4. Alright, so because y squared had the larger denominator, we know we've got a vertical major axis. We want to go 5 up and down. So the vertices on the major axis are on the y-axis, so 0, positive, or -5. And then to complete the sketch, we want to go using B, 3 left and right. So that tells us how wide this thing is going to be. There we go. All right, and then we want to figure out the foci. Those will be on the major axis, which is the y-axis. So the x-coordinate will be 0, and then we'll have positive or -4 from plus or minus c. And asked us for the length of each axis. So the major axis length is always 2a. In this case, that is 10. And the minor axis length is always 2b. In this case, that's 6. So vertices, foci, we might as well put on the graph too. There we go. And then on to the next one. Find the equation of the ellipse having vertices at positive or -5, 0, and foci at positive or -3, 0. This gives us all sorts of information. So the vertices are always going to indicate what A is. So A would be 5, and the foci will tell us what C is. So we know A is 5, B is not known, C is 3. And because the x-coordinate is the non-zero coordinate for each vertex, we know that the graph has also a horizontal axis, or horizontal major axis. Right? To get b, we can use that c squared is a squared minus b squared. If we rearrange and solve for b, we have b squared is a squared minus c squared, which in this case is 25 minus 9, or 16. So b is 4. All right, since the horizontal axis is the major axis, we want a to be under a squared underneath x squared. So x squared over 25, and then y squared over b squared, which would be 16, equals 1, should be the equation of this thing. And then we can see from the equation that the x-intercepts should be 5 and negative 5, 0, which fits with a equals 5, and the y-intercept should be 4 and negative 4, 0. So we can get a sketch of this thing. Let's see, and then the foci, we can put on there 2, 3, 0, and negative 3, 0. And I think that's all they asked for. I just want to look back and compare this graph with the one we just did. It's not real dramatic, but notice when the foci are further from the center, the graph of the ellipse is a little bit longer and narrower. And here in the next one, where the foci moved a little closer to the center, the graph looks a little more circular. And the closer these points are to the center, so the closer the foci are to the center, the more the graph will look like a circle. All right, the next one, consider the equation x squared equals 4 minus 2y squared. Find all the key features and sketch the graph of the equation. So we've got x squared equals 4 minus 2y squared. Key is first to get the graph or the equation into standard form, which means we want the x squared and the y squared terms on one side and a 1 on the other side. So if we rearrange, we'll have x squared plus 2y squared equals 4. And then if we divide everything by 4, we'll have x squared over 4 plus y squared over 2 equals 1. And now we've got standard form because we've got a 1 on one side and the x squared and the y squared terms on the other. All right, so now we try to figure out what's a squared, what's b squared, what's c squared. Remember, a squared is the larger denominator, so we have a squared is 4, b squared is the smaller denominator, in this case 2. So a is 2, b is the square root of 2. C squared is always a squared minus b squared. In this case, that's 2. 4 minus 2. So c is also the square root of 2. Because x squared had the larger denominator, we know that the major axis is going to be horizontal. So we've got 2, 0 and negative 2, 0 for the vertices. And the foci will be on the x-axis, so the y-coordinate will be 0, positive or negative square root of 2, 0. The major axis length will be 2a, which is 4, and the minor axis length is 2b, which is 2 times the square root of 2. Okay, so our graph isn't going to be perfect. B, we wouldn't know exactly without a calculator, but square root of 2 will be between 1 and 2 somewhere. So on the y-axis, we'll put a point in between 1 and 2, and we'll just connect these. All right, then the foci we might as well put on the graph as well. Roughly there. All right, I think that's everything for that example. Next one, consider the equation 9x squared plus 4y squared equals 1. Find all the key features and sketch the graph. This one is very similar to the last one, except that it's already technically in standard form because we've got our x squared and y squared terms on one side and a 1 on the other. Just to be careful about a squared and b squared, it helps to rewrite this into complex fractions. Multiplying by 9 is the same as dividing by 1/9, so even though it seems awkward, we could write x squared over 1/9 plus y squared over 1/4 equals 1. So we can see 1/4 is actually the larger denominator, so y squared is indicating the axis that's the major axis. So the major axis will actually be vertical. So a squared is 1/4, b squared is 1/9. And that means a is a half, and b is a third, and c squared would be a squared minus b squared, which is, in this case, 1/4 minus 1/9, get a common denominator of 36, have 5 over 36, so c is going to be positive or negative square root of 5 over 6. And once we have all of those values, we can write down the key features and then sketch the graph. So again, the y-axis is going to be the major axis. Let's see, I'm just going to mark these as this is half and negative a half, and a third and negative a third on the x-axis. For the points where the ellipse intersects the x and y axes. Just using a and b, and then the foci will be on the major axis, which is the y-axis. So let's write down vertices on the y-axis are 0 for the x-coordinate, positive or negative a, so positive or negative a half. The foci also on the y-axis, so 0 for the x, and then positive or negative square root of 5 over 6. And let's see, the major axis length is 2a. Which would be 1. And the minor axis length is 2b, which would be 2/3. And we can put the foci on there. It's hard to estimate that very well, but we know they'll be somewhere between 0.5 and 0 and -1/2 on the other side. I think that's everything for that one. In example 5, we're trying to build an ellipse out of a rectangular board and make the ellipse as large as possible. So it says here that we're trying to build a tabletop from a 4-foot by 8-foot piece of plywood using what's called the thumbs, tack, and string method, which is easier to demonstrate in a face-to-face class. But the idea would be this: if you put down 2 thumbtacks at the foci of your ellipse and grab a piece of string and connect the string to the foci, and then slide that string around using a pencil, the sum of the distances between the 2 foci, those lengths, is going to stay the same as you move. And you'll end up creating an ellipse as you pull that string around. So the carpenter is going to use that method and try to build an ellipse for a tabletop, and we want to use as much space as possible. So we need to figure out what length of string he should use and how far apart the tacks should be to get the largest possible ellipse. So what we would want is for the minor axis to go all the way across the 4-foot side, and the major axis to go all the way across the 8-foot side, and for the center to be right in the center of the piece of plywood. So just using that much information, we can figure out, well, we would want A to be half of the 8-foot side, so 4, and we would want B, the length of half the length of the minor axis, to be 2. And we can get an equation for this here if we want to, if we think about the origin being at the center and then the horizontal axis being the major axis and the vertical axis being the minor. The question doesn't ask for this, but we would have x squared over 16 plus y squared over 2 squared, which is 4, equals 1, would be the equation of this thing. And we would want to figure out where the foci would be. And if you look back, you want to remember that c squared is a squared minus b squared. So we've got c squared equals a squared minus b squared, which in this case is 16 minus 4. So we'd have 12. So c would be positive or negative. Square root of 12. We don't want to take c to be negative, so square root of 12, which is 2 times the square root of 3, right? And we would need an approximation for that if we're actually going to measure it. So we would do square root of 12, so approximately 3.464. So we want to have the tacks be that distance from the center. Both directions, right? So the two questions we have here, what length of string should he use and how far apart should the tacks be to get the largest possible ellipse? So the distance between the tacks we would want 2c. So 2 times the square root of 12, which would be approximately 2 times 3.464, and that would be in feet. So that's how far apart we want the tacks. That's just the distance between the two foci. And then the length of the string, you can picture when you're on that major axis. You would have all the way across between the two foci, and then you would have this distance on the end between one focus and the vertex. You would have that doubled. So you can imagine that the distance of the length of that string would really stretch all the way across the whole ellipse. So basically you want 2a, which in this case would be 8 feet. Right. So again, the way I'm getting that is by picturing when that string is stretched across to get the point on one end. We would have one attached here, one attached here. We would have a piece of string going all the way there and then coming back. And so you can imagine that if it were detached from those foci, those two tacks, you could stretch it all the way across the length of the ellipse on the major axis. So that's the answer to both questions. The length of the string would be 2a, and the distance between the tacks would be 2c. Okay, example 6. For a particular ellipse, the endpoints of the minor axis are 0 plus or minus 3. So we can see that the minor axis is vertical. From that information. And it tells us the distance between the foci is 8. And from that information, we can tell that c would be half of that. So 2c is always the distance between the foci, which would imply that c is 4. And the distance, half the distance, or half the length of the minor axis is b. So we can get from this information that b is 3. And we're always needing to know a and b and c to have all of our pieces put together. So c squared is a squared minus b squared. And I'm trying to find a, so a squared would be c squared plus b squared. In this case, that's 16 plus 9. So 25. So a would be 5. So the equation of the ellipse would be the major axis is horizontal, so x squared over a squared. X squared over 25 plus, the y squared over b squared, because the minor axis is vertical, and then equals 1. If we wanted to sketch it, we could go 5 this way, 5 that way. Those are the endpoints of our axis. So the two vertices are at plus or minus 5, 0. And then the foci, if we wanted to draw those in, c was 4. So 1, 2, 3, 4. 1, 2, 3, 4. Always on the major axis. Alright, so the next one is a little more interesting because the center is not 0, 0. What you want to remember is that our standard equation, if the center is 0, 0, looks like this. But the thing that's different here is that we have, instead of an x in the parentheses squared, we have an x minus 2. And instead of just a y squared, we have a y plus 3. So if you remember back to circles and what the equation of a circle looks like for a center that's not 0, 0, that review would help. So when we have x minus 2, we're going to have a shift to the right. And when we have y plus 3, that's going to be a shift down. So each of them is sort of opposite of how they look. The changes impacting x will be horizontal. The changes impacting y will be vertical. X minus 2 will go right 2. X plus 2 would go left 2. Y plus 3 is going to go down 3. Y minus 3 would go up 3. So the shifting will change the center. So instead of the center being 0, 0, now the center is 2 from the right 2 and negative 3 in the y coordinate from the down 3. Okay, so now we know where the center is. Let's go ahead and sketch that. 2 to the right and 3 down. The rest of it, we just kind of work through the same way we had, but when we sketch, it's all in relation to where the new center is. So we still have a squared is 16, because 16 is the larger of the two denominators, and b squared is 9. And we can still see that because the larger denominator is under the x term, we have a horizontal major axis. And if a squared is 16, a is going to be 4. So those two pieces of information tell us that we want to go 4 left and right of the center. For the vertices. So if our center is 2, 3, or sorry, 2, -3, our vertices are going to move horizontally. So 2 plus or minus 4, still -3 for the y. So that means 2 plus 4 would be 6, -3 for one vertex, and 2 minus 4 would be -2, and then -2, -3 for the other. So we've got our vertices, and then we use b squared to find b, and that tells us how far to move up and down to get the minor axis. And still from the center. So our minor axis endpoints will be keep the x coordinate the same, but do -3 plus or minus b, which in this case is 3. So up 3 and down 3 from the center. So we've got 2, 0 or 2, -6 for the endpoints of the minor axis. So we've got a sketch of the thing, and we would want to also find out where the foci are. They will be horizontally moved from the center because the major axis is horizontal, but we need to know what c is. C squared is always a squared minus b squared. In this case, that's 16 minus 9, so 7. So c is the square root of 7. So the foci we want to move horizontally, so 2 plus or minus square root of 7, but keep the vertical coordinate the same, so the y coordinate stays -3. Square root of 7 has to be between 2 and 3, so go between 2 and 3 to the right and the left, and those are our foci. I think that's everything we needed. A few more examples with centers that are not the origin. In example 8 here we have an ellipse where the vertices are located at 3, 8 and 3, -2. So let's sketch that first. 3, 8, 1, 2, 3, 4, 5, 6, 7, 8 way at the top, and 3, -2. That much information also tells us where the center is. So we can discern that the center then is halfway between the vertices. In this case, since those are, let's see, what, 10 apart vertically, the middle would be just 5 down from the top. 1, 2, 3, 4, 5. So that would be, what, 3, 3? So the center is 3, 3. And we can also tell from that information that the major axis is vertical. We can also see that we know that A is half the length of the major axis, and that major axis is 10 wide, or 10 tall, I should say. So A is 5, right? The distance from the center to a vertex. All right, so that's quite a bit of information just from the vertices are located at 3, 8 and 3, negative 2. We also have then one focus is located at 3, 5. So if we think about what that tells us, 3, 5, the distance between the center and the focus is C. So C has to just be 2. So now we know A is 5, C is 2, C squared is A squared minus B squared. So B squared, if we rearrange that, would be A squared minus C squared, which in this case is 25 minus 4, so 21. So B would be the square root of 21. We're looking for the equation and the graph. Square root of 21, we can use that to figure out how far away from the center we should move for the minor axis. That's got to be between 4 and 5, because square root of 16 is 4 and square root of 25 is 5. So we're going to move horizontally just a little over 4 away. 1, 2, 3, 4, so maybe somewhere in there. 1, 2, 3, 4, that way. And so this endpoint would be, let's see, the center was 3, 3. So 3 plus square root of 21, 3. We wanted to add square root of 21 to the x. And this one would be 3 minus square root of 21, 3. Moving to the left. And now we've got at least the sketch of this thing done. There we go. And we still need the equation. We've got some room here. We know we want y squared over a squared because the major axis is vertical. So y squared over 25. Except that I just forgot about the center. Not just y squared, but y minus 3 squared. Let's try that again. So y minus 3 squared over 25 plus x minus 3 squared over b squared, which we figured out was 21, equals 1. Okay. Next one is given to us in what's not standard form. So what we need to do is complete the square 2 times, once with an x group, once with a y group, and then use the information that we have to figure out the center, vertices, and foci. But the first step is to rewrite the equation. So we need to complete the square twice. To get standard form. Which we're looking for like x minus h squared over a squared plus y minus k squared over b squared equals 1, or y minus k squared over a squared if we have a vertical major axis, plus x minus h squared over b squared equals 1. So that's the form we're trying to get to. So what we want to do is group the x terms together and leave a space with a plus sign next to it because we're going to add something. And then group the y's together and leave a space. And then any constant term you want to move to the other side. So I'm going to subtract it and I'll have negative 9 on the other side. So far I've just set things up so that I can see that I want to add some terms on the left side, and then I'll add the same values on the right side. And move my constant to the other side. Then I need to be sure to factor off if there's a coefficient that's not 1 on either of the variables, I need to factor that out. So my next step is going to be factoring out this 9 from the y group, still leaving a plus and then a space to add something. I'm not going to change anything on the x's because the coefficient is already 1. But factoring out the 9 on the y squared, and then also on the linear term right next to it. Then I need to figure out what to add, and I always want to add half of the linear coefficient squared. So here I'm going to take 6 and cut it in half and square it and add that right there. And on this one I'm going to take the 2, not the 18 from the previous line, but the 2, cut that in half, oops, and I'll get 1, and I'll square that. If I had taken the 18 instead, then we need to put these numbers in each group. So half of 6 squared is 3 squared, so that's 9. And anything we add on the left, we have to add the same thing on the right. And here we've got half of 2 squared, which is 1. Squared is still 1. But on this one, what we really did, when we wrote that 1 there, we really added 9, because we have 9 times 1. So on the other side, I need to add a 9 there also. Oh, I was going to say that if I had looked back here and taken the 18, I would have taken half of 18, which was 9, and squared it. I would have added 81, and that's not what we wanted. So it's really important that you factor that coefficient out first, and when you decide what to add, you look at the new coefficient on the y, take half of that and square it. Okay, now what we want to do is rewrite these trinomials, these groups of 3, as binomials squared. So if I'm going to factor x squared plus 6x plus 9 into a binomial squared, I certainly have to have an x as my first term, and then to get this 9 I need a 3 squared. And because the coefficient on the 6x is positive, we want a plus in between. And then we've got a plus between these groups. The 9 stays out, and I'm just trying to rewrite the y squared minus 2y plus 1 as a binomial squared. So keep the 9 outside. If I'm going to rewrite this group as a binomial squared, I need y to get y squared. I need 1 to get 1 squared. And then in the middle I want a minus because the middle term here has a negative coefficient. And then on the other side I've got negative 9 plus 9 plus 9, so 9 there also. And then if you compare what we're trying to get to for our standard form, we don't want any coefficient here other than 1 in the numerator. So I want to divide both sides by 9, which is also going to give me a 1 on that other side. So really it's we're more concerned about getting a 1 over here, but that's also going to take care of the 9 right here. So divide both sides by 9. And again, the reason really that we're dividing by that 9 is because we want a 1 on the right-hand side. So we divide everything by 9, and that gets rid of both of these 9s. So now we're looking at x plus 3 squared over 9 plus y minus 1 squared over 1 equals 1. From this we can see all sorts of information. We can see from the shifting that the center is negative 3, 1. X plus 3 means we're going left 3. Y minus 1 means we're going up 1. We can see that the major axis is horizontal because the larger coefficient is on the x squared term. We can see that A is 3 and that B is 1, because A squared would be 9 and B squared would be 1. So that tells us that C squared is 9 minus 1, or 8. So C is square root of 8, which is 2 times the square root of 2. So we should be able to sketch this pretty well. The center is negative 3, 1. Because the major axis is horizontal, the vertices are left and right of the center, moving A left and A right. So negative 3 plus or minus 3 keep the y-coordinate the same. So the vertices will be 0, 1 or negative 6, 1. The endpoints of the minor axis will be negative 3 and then 1 plus or minus b, which in this case is 1. So we want to go up and down 1 from there. Oops, not from there though, from the center. Let's try that again. Didn't want to lose all that. So from the center, up 1 and down 1. There we go. So this is negative 3, 0 and negative 3, 2. We've got our sketch. And the foci are at along the major axis, so left and right of the center. Negative 3 plus or minus 2 square root of 2, 1. Let's make sure we answered everything here. We've got the equation, we've got the graph, vertices and foci we have, and the center we have. So you might want to review a little bit the completing the square process, but it'll come up in the next couple of videos as well. Last one, for a certain ellipse, the foci are located at 2, 5 and 6, 5, and one vertex is located at 10, 5. And we want to figure out the equation of the ellipse. Again, I would start with a sketch. So 2, 5 and 6, 5. Two, 3, 4, 5, 6. The center has to be halfway between the foci. So that would be, what, between 2 and 6 would be 4, 5. So the center is going to be 4, 5. And we can tell there's a horizontal major axis. So we can get a start on this equation because we know the center is 4, 5. We know we've got this in each numerator, x minus 4 squared and y minus 5 squared, shifting right and up. From this information, we can also see that c, the distance between the center and the focus, is 2. So we know that c squared is 4. And it tells us one vertex is located at 10, 5. So the center was 4, 5, 6, 7, 8, 9, 10, 5. So if this is 4, 5, and this is 10, 5, the distance there between the center and a vertex, that would be A, and it looks like that distance is 6. So we're using that A is the distance between center and vertex. And in this case, it's going to be 6. So a squared is 36. And we still need to figure out what b squared is. But since the major axis is horizontal, I can put this 36 under the x squared term. And c squared is a squared minus b squared, so b squared is what we're looking for. That would be a squared minus c squared. So in this case, that's going to be 36 minus 4. So b squared is 32. B is the square root of 32. 32 is 16 times 2, so we could simplify that to 4 times the square root of 2. In the denominator here, we want b squared, so 32. So we've got the equation all worked out. That was our goal. Let's go ahead and finish the sketch of this thing. If one vertex is at 10, 5, and the distance between the vertex and the center is 4, the other one has to, or sorry, is 6. The other one has to be 6 left of the center, so negative 2, 5 for the other vertex. And we figured out that b was the square root of 32, which would be between 5 and 6. The square root of 25 is 5. The square root of 36 is 6. So let's go not quite 6 up. Oops, up from the center, which is over here, and not quite 6 down. So the endpoints of the minor axis are 4 and then 5 plus or minus square root of 32. Or simplified, that's 4, 5 plus or minus 4 times the square root of 2. Same thing. There we go. And my sketch is a little bit strange because my scale wasn't perfect all the way across, but rough sketch at least. Okay, so the main thing is you want to just remember that the A and the B and the C mean the same thing they did before, but when the center is not 0, 0, you need to move just the distance, the appropriate distance away from the center. So A is always the distance between the center and a vertex, and B is always the distance between the center and one endpoint of the minor axis, and C is always the distance between the center and the focus.